Hi, I'm going to tell you a little bit about this max patch by Aaltan Ahmad, who made this in 2012. First, just a sense of what the endpoint or the whole reason for this patch is. That is that Aaltan wanted to create 4 buffers that he could play into in live, in a live format, and then each of these buffers would be the same length of time, so they could be coordinated in real time. That was the endpoint, to create sort of 4 or 5 tracks that could be laid on top of each other and coordinated. So I pre-recorded some really sort of third-rate singing just to give you the idea of how this works. So here's what I laid in first. La 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 la. La 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 la. Okay, and then I put in another track in this second one that I will attempt to coordinate with the first. La 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 la. La 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 la. Harmony a little bit. La 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 la. And then I could add a third track. La 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 la. La 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 la. La 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 la. La la. Okay, so you get the basic idea of this patch is to create this counterpoint. So so what I'm going to do is go in and show some of the detail of how Aaltan made this happen. Okay, so the first thing I'd like to show is how Aaltan is using a subpatch here. So in order to create a subpatch, what we do is go in, unlock the patch, let's say, and if we create a new object, just a moment, sorry, create a new object, P space, and then whatever, let's say it's track 7. Okay, and then click outside that object, and this subpatch appears. Notice that it says in brackets track 7. Okay, and so now whatever I have in this subpatch, of course, is connected to that patcher. So I'm going to double click on one of Aaltan's subpatches, and when it's locked, and I will copy all of it and go to my subpatch here and just load it in. And notice when I did that, this subtrack of track 7 suddenly has 4 inlets on top and 1 on the bottom. Why is that? You can see that Aaltan had created in his subpatch 4 inlets, and these correspond to the inlets on the master object for this subpatch. So it has 4 inlets and 1 outlet. So to create an inlet, we simply make a new object and call it an inlet, surprisingly. So if we create another inlet, you see we have inlet number 5. If we made some feature to that, of course, we could connect it up, and we have now 5 inlets on the object, but we don't need 5 inlets. So now we can look at what this object is doing inside of Aaltan's patch. So we can ignore for now the inlets and just look at what this patch is doing. You see this patch has 3 main components. Record, which takes the sound in from the ADC. I have a level set on the ADC, so it's reading I know the mic is working. We have the buffer, which is 10,000 milliseconds or 10 seconds long. That's what this argument determines. It reads the name and the length of the buffer. When it's locked, if I double click on the buffer, I see a representation of that buffer and its waveform. So this buffer does have sound in it. The third aspect, or sorry, third component of the buffer is the playing mechanism. In this case, it's a groove tilde. So the groove tilde is a little bit of a complicated object. It requires a number of additional objects in order to get it to work. So this signal, or SIG tilde object, is essentially, in this case, turning it on and off. So when I click it on, now I get that sound. And the loops obviously loop that sound. Okay, so there's another important aspect to this groove object that we should understand, and that is the set loop message. So these gray objects are messages. So this sends this message set loop, and that means it sets the beginning of the loop to 0 and the endpoint to another number. If I went into this object, this message, and changed the endpoint to 1500 milliseconds, then it should play only from the beginning up to 1500. You see how only the first part of the buffer is being played. So if I changed the 0 to, say, 1000, obviously then it would start 1000 seconds into that 10,000 millisecond. Sorry, I said milliseconds, where I should have said seconds. Anyway, this second object, the second number in the argument, determines the starting point of the loop. Okay, so why the $1 sign? Okay, that's the critical component here. Remember that Aaltan's whole idea was to determine the length of the loop based on when it was started and when it was ended. In other words, the length of the loop will be simply the interval of time between the first click and the second click of this, over on the left here, this toggle. So that is accomplished right here. So if we make this into a $1, what that does is it tells us that whatever number is coming in to this inlet here will replace that $1. So if I make a number object and let's say and attach it here and make and now I start to play it, let's say now it's very, very short, just 300 milliseconds. I'm changing the length of the loop on the fly. You see, now it's 4 seconds. Okay, so if you get that, then the key is that Aaltan made this clever timing machine to determine the length of the loop. All right, and he's got that coming in here into this inlet. Okay, so perhaps we mostly understand this subpatch at this point. Okay, so now we'll go to the timer that he set up, and this is in this subpatch here. So what the timer does is you have two bangs, one on the left and then one on the right, and the timer times the interval. So if I hit this one now and this one very quickly after, that was a second, 1.2 seconds. See if I can go faster. 733. It's hard to do that very quickly. Do you see how it times the interval in between these two clicks, the left to the right? So we have another object here. It's called a gate. G gate is its name. I did that just so you can see where you get it. Okay, and what the gate does is it just switches left and right alternatively. So how does this timer then time the clicks between time the interval between clicks of this toggle? Well, what Aaltan used was the send device, or send object. So if I make a new object, send whatever it would be, number, and then I make another object, receive, and then make sure I name it the same way, number. Now this receive will, it's obviously receive that number. So I'll make an object, a number object, and feed it into the send number, and make another object, number object, and see how this mechanism works. So now whatever number I'm putting into send is coming out receive. Simple technique. So Aaltan uses that to he connects a send time 1 start to this toggle. So where is receive time 1 start? You find it? It's way up here. Okay, so that whenever that's hit, we get receive time 1 start. That goes into the timer. It's quite an ingenious device, I think. Goes into the timer. Where in the timer? On this inlet, right? Okay, so it'll switch then from this this button to that button, and then we'll output the amount of time between those two events. That in turn, we have received it. Oh, sorry. Let's go back. So that is sent out of this subpatch in outlet 1, comes into this, comes out the subpatch here, and then it's put into send time. Where's receive time? It's right here. Okay, where does receive time go? That's inlet 1, 2, 3 in the subpatch. 1, 2, 3. Okay, so that number comes in here, set loop, and then is read by $1, sets the length of the loop. And presto, the length of the loop is made to correspond to the interval between the clicks on this toggle.